Okay, so reflections probably are not something that's necessarily new to any of you. It's something that you did to a certain extent while you were in Algebra 1. Today we're going to take reflections to a bit of a bit further. Let's look at our first example here when we're reflecting something over a line. Really what you want to do is you want to consider the vertices of any of the polygons that you're going to be reflecting, and the vertices are the things that you really want to consider reflecting. Okay, for instance, the point C here, we want to consider that we want to reflect that point across the line so that it's the same distance away from the line on the other side. Okay, and that new point is going to be called C with a little dash up there. That's called C prime. Okay, I'm going to do the same thing with point B, and really what you want to do is you want to reflect these points across the line perpendicularly, meaning if you can, reflect them at about a 90-degree angle. So you don't want to reflect B and have it way down here. Okay, you want to reflect B and you want it to be as perpendicular as you can from the line. So if you consider a line crossing at like a 90-degree angle here, you want this point B to reflect somewhere about right here. Okay, now what we're going to do in class is we're going to actually take a ruler and we're going to do our best to reflect these as perfectly as possible as we can given the instruments that we have. Okay, and then lastly I got to take point A and I'm going to reflect point A across the line as well. This would be my A prime, this was my B prime, and then I'm just going to combine those, connect those dots, those vertices, and that's going to be my reflected triangle. Okay? Alright. Second one here, we're going to go ahead, we're going to reflect this thing. The point P isn't reflecting at all. The point O would reflect over to here, that's my O prime. The point N would also reflect over to here, that'd be my N prime. Point L going to reflect across the line as well, and point M will do the same, M prime, L prime, and then we're going to go ahead and we're going to connect these. Now tomorrow in class, when we're working in class on some of these, we'll talk about how we definitely want to use a straight edge, and in some cases we're just going to go ahead, we're going to measure to make sure that we get these to be as close to perfect as possible. Alright, what if we're asked to reflect something twice, which would be the case here? I want to reflect it across, let's call this line M, and we'll call this one line N. Okay, and I'm going to reflect this thing twice. Well, point G reflects here. That's my G prime. Point A is going to reflect to here. That's my A prime. Point, I mean, it's up to you as far as where you want to go from there. If I reflect point F, that's here, but then point E is, even closer back here, closer to the line we're reflecting. D is even further away, so point D is going to be up in here. And the only other two, we got point C, which is going to be the furthest away. That's my C prime. And then, let's see, I got A. The only other one is B, which I haven't reflected yet. That would go somewhere in here. Okay? I know that looks kind of messy, but when we reflect all those points, what we end up with when we connect the dots, here, 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 and then here. Oh, I guess I didn't reflect that C quite far enough down here. So that's C here. Let me move that one over to there. Okay. So it looks something like that. That's the reflecting down of it. Now I'm going to reflect it again. Okay, I'm going to reflect it again, and we're going to call these double prime when we have these points here. So the C reflects, we'll call that C prime prime. Okay, the D then reflects. That's actually, let me just move that one down a little bit because, oops, I don't want all those to be together. Okay, I'm going to have to erase this. The D reflects a little bit further away from the line than the C is. Okay. Let's see, then we have a B that reflects in here. Sometimes this gets a little sloppy when you label all the points, but so let me just do part of this without labeling the points. And then G is down here. You have F somewhere in here. And then you have this E that's the furthest away. Boy, this is going to be a little on the sloppy side. Okay, so C connects to B. B connects to A. A connects to G. G connects to F. F connects to E. E connects to D. And D connects to C. That does not look very good at all. Okay, we're going to have to try that one in class tomorrow. Pretty ugly. Try that one on your own. Show me that you can do it better than I just did. That wasn't very good. Okay. Now this one says to use a composition of reflections to find the rotation image with respect to lines M and N. So basically what we're doing here is we're going to rotate it all the way around. Okay? We're going to start by rotating this way. So if I kind of flip this over the axis, and I rotate each of those lines, this is my E prime, this is my D prime, and F prime. Combine those. Then if I reflect them again, okay, you're going to get something that looks, it's just kind of reflecting down like this. And then when we reflect it again, it looks something like this. Just make sure you label your points. Okay, so this is my F prime prime then. This is my D prime prime. And then this is my E prime prime. And then when I reflected it again, this is triple prime, and triple prime. And then as you can see, as I reflected that back to the original, I would end up back with where I started. Okay? All right. So, reflections on the plane. Okay? I'm just going to do one of these because I'm already getting short on time. But one of these should be sufficient to at least get you going on doing the rest of these. So, if I'm going to reflect B across the axis, my new B is going to be, the x-axis is what I'm reflecting over, so that's here. So my new B is going to be right here. I'm going to call that B prime. My C, if you look, this C is currently 1, 2, 3, 4, 5, 6, 7 units from the axis. I got to go 7 down. 1, 2, 3, 4, 5, 6, 7. That's my C prime. And then the A is 4 units down because it was 4 units above. So the big idea here is this. If we consider the fact that my original A was the point -3, 4, and my new A is -3, -4, we notice that flipping over the x-axis just changes the sign of the y value. Flipping over the x changes the sign of the y. Alright, my original B was the point 4, 2. That became 4, -2. My original C was the 0.37 that became 3, -7. So once again, if I'm going to flip over the x, my y's are all changing. You can probably guess that in this problem, when I flip over the y, it's going to be my x values that the sign is going to change. My y values should stay the same. Okay? And then in the last example, the question here becomes, okay, if my original point is an xy point, what is happening to that in order to get my new points? Well, it looks to me like to go from B here to B here, I'm going down 1, 2, 3. So I'm going down 3, and I'm going to the right 1, 2, 3, 4, 5, 6, 7. Right 7. So what does that mean as far as our x's and our y's? Well, my x values are my left and right. So if I'm going to the right 7, all of my new x's are x plus 7. My y values are my up and down. So my y values, I'm subtracting 3 from each of those. That would be a description of a translation to take this from one to the next. Okay, so finish these up. Anything, especially this slide here, make sure you finish that one up before class tomorrow, then we're going to work on some of these. Oh, and do your best to show me this a lot better than I did. It shouldn't be too tough to do.